And do you see this file?
Yes.
Okay, make a shortcut and add this shortcut to your Google Drive everywhere. It is not very important, but it should be in your Google Drive.
Where is this? It's in the latent space, and then what? On the first results folder or IP?
In the
chat
no,
box. He sent a link
on the chat.
Yeah, he sent a link to his drive, and then you will just select network snapshot, PKL, right click, and you will create a shortcut in your drive.
There are two snapshot network, the 10 and the 000.
10.
Yes, the 10. And just add a shortcut to your drive so you can use it. And after that, go to Colab and go to the left menu and locate that snapshot, this file, the network snapshot number 10.pkl in your Google Drive. Locate it and paste the file path to this part and paste it here.
And the first one, what we have to do on the first line?
It should be the StyleGAN ADA2, this one. Copy the path of this one. So
okay.
So
and the result path?
Result path is going to be something arbitrary, whatever you want, but create some folder and name it, for example, as I have done it, latent space exploration. And under that, create another folder and name it. Oh, this is something I should be careful. Name it, for example, first result folder. So you see.
But we have to create a latent space exploration too.
You can name it anything. It's just for being consistent and sticking to some organization.
Okay, yes. Mohammed.
Yeah.
In your drive, this snapshot 10 pkl actually is under the folder My Images, right?
Yeah.
Okay, this My Images is under the folder Results.
So yes, you should just locate the file and copy the path.
Yeah, I have already did it, but I already copied your deep architecture using AI and architecture to my drive. That's why I am seeing all the files. I'm just actually trying to understand. I am seeing many network snapshot files in my drive. Yes. That's why. Okay, I will select just 10.
Mine didn't work. I just read. I don't know.
Yeah. So you created the result path folder and copy and paste it here, and the network snapshot path in here, and StyleGAN to ADA in here. So after that, you have just to run this code, this cell, and it is like this.
But it's not working. It cannot read.
Okay, OS is not defined. Okay. Let me, I will send you this. It should be in the first part, as you see here. It should be like this. Okay.
Well, I have that, but there's an error. Trace back.
Yeah, I will send it in Discord. So you just have to copy it and paste it. But be careful. Let me just don't copy it, and let me just from this part, because if you copy the other parts, it will be some problem. Okay, and yes, copy this and paste it here in this part, paste it here, and after that execute this cell, and you are good to go. As you see, there will be no error.
No, there's still error.
Did you copy it?
I had the same problem. Something from the path that's wrong. It's not a problem with the board. Once I solve the path, it stops the problem.
Okay, Adrian, let me. You are a host now, and share your screen,
I think it's
please,
better
so
for Isogol. Sorry, I don't know how to speak your name.
Okay. I will make.
I don't have any problem. It's worked actually.
Oh, so it's Angelica that has a problem?
I think so.
Yeah, okay.
Yes, so you have to make her a co-host because you are now the host, and you should make her co-host.
Sorry.
Host. Yes, that's okay.
Make host. Yes.
So Angelica, can you share your screen? Okay.
Okay, so show me where is your file?
No, let me. Okay, Angelica, go to Discord.
Where?
Discord is up.
Okay, yes. Right, I copied.
Yes, copy that path.
Yeah.
And go to the collab.
From here?
Yes, copy this and go to collab. And from TensorFlow, you know from the beginning of the line, TensorFlow, highlight it. Yes. Highlight all of them until the end of the codes, until the end of the set.
And so paste it here.
Yes, paste this code here
like
and
this.
Execute it.
Okay, I was pasting just from import OS, but it's not
run it. DNN lib. So let me. Okay, so you have
the path. I had the same
path. Yeah, you have go to the left menu and collab SG2 ADA. Under that, collab SG2 ADA. Under that, you have another folder that is called StyleGAN2 ADA. Copy the path of that folder.
Yeah. And?
Yes, and paste it in StyleGAN2 ADA path.
Okay.
So now you can run it. So we are good to go. Okay. So can you make me host? Sure.
Yes.
Okay, thank you.
Okay.
So I'm host. Let me share my screen. Okay. So, and now we have to, you see this define interpolation strategies, and there are 2 cells here. Just run it. It is nothing, but you should just run it. It is like 300 lines of code, and there is nothing we want to know here. Just we want to run it, and we are good to go after that. For example, here, it will take a couple of seconds to be run, and let me run this, and I think, yeah, it is okay. So it is okay, and go to, for example, generate samples, and we have on generate one image. For example, if I want to generate one image, as you see here in this part, I have created a folder under, for example, latent space exploration folder. I have another folder that is first folder result. So it will be saved here now. And seed, what is seed? Is like seed. is something that enables you to select randomly generated seeds from the model. And you should bear in mind that our StyleGAN input is a 1024 dimensional array. These seeds are used to generate the 1024 bit values. Each seed will generate a unique, randomly generated array. So additionally, the same seed value will always generate the same random array, which can be used for other purposes such as interpolation. So you see, if I and the truncation PSI, we have something as truncation PSI. And what is truncation? Truncation enables us to discard portions of the latent space that are underrepresented in the latent space. We want to specify how close to the average the generated intermediate, for example, our vectors should be. And we will see through the collab that is called truncation PSI. The PSI value scales the deviation from the average of our vector, our random vector, and thus, so it can be adjusted to account for quality or variety trade-offs. So, for example, a PSI value of 1 corresponds to no truncation. So, yeah, it means that the values closer to 0 bring us closer to the average, that it will improve the quality but reduce the variety. So a value of 0 will reduce the variety and but improve the quality. As you see here, for example, it is the best quality but the least variety of the image. But if I go here and put it like that, it will improve the variety, but it will decrease the quality. So I'm going to stick to this and to the best quality now, but I'm going to have some experiments with this. And I just run it, you know, and it is going to take a couple of seconds. And after that, you see that there are some messages. And when it is done, we are going to see the result. So let me, and I will be there. Let me just see if it works for me. And after that, I will come to see what's the problem with your code. So there is nothing wrong with me. What is the error? Can you tell me? Or can you copy and paste it in the chat box, maybe?
Of course, I'm sending it from Discord.
Okay.
I ran it and it's like green light, green check.
So okay, so
I have to see the image on the.
Oh, yeah, Aishegul, you know that you did not run this part, yeah? You did not run these code.
Okay, 3 interpolation. Okay, okay.
So after that, you are good to use this. And let's check what's the result. And let's go back and back here. Let me check what was the, so AI latent space, okay. AI and latent space exploration. So you see first folder result, the result is going to be saved here, for example.
It will make,
yeah, it will save something, for example, like this, because we have, now we can, you know, we don't have, sorry, we don't have any limits in the number of the images we can create. We can create tons of images. For example, let's go and to generate multiple images. For example, let's see, every time you want to create something new, it's better to create a folder for that. For example, I'm going to create another folder in here and called it second. It is really big. So folder 2, for example. It is a little bit smaller. Its name is smaller, so easier to read. And just paste it here. Copy the path and paste it in the result path, and execute this this cell again, because we want to update the path. So it is, yes. For example, I want to generate multiple images. I want to run another code. I want to have some other images. Yeah. Every time.
Where is the generate multiple images? I can't find it.
It is under generate one images. We have generate multiple images here, you know. And every time we want to explore the latent space and have some inferences, some other inferences, some new ones, it should be like this. It's better to do this, to create another folder for that experiment. For example, I want now to have to generate some other images. I go under my latent space exploration and whatever you called it or named it, and create another folder that is res2, for example. Let me delete it and create it so you can see. And just it is okay. And create another folder, a new folder, and name it, for example, folder res2, and press enter. So that's it. And let's wait. Okay, so I copy the path and go up here. So up here under the result path. So I want my new folder path to be updated, and again run it. So it updates the result path. So after that, now I'm good to go to use this part, the generate multiple images. For example, end at 1,000 maybe, and we want 15,000 of images. Start from 0 seed. Okay, so 0. Let me, what's happening? Okay, start from seed number 0 and end it at seed number 1,000, and we want 250 images. So that's it. And the truncation PSI is like this. We want a lot of variety because it is closer to 1. And I told you that PSI of value 1 is related to more variety and less quality. And if I just take it to this part, it will be like something like that. If I take it here, it will be, because it is closer to 0, we have more quality and less variety. So I just put it here, or maybe here, and let's run it. So after it is run, it is executed, we will end up with 250 images in our folder, and it is going to take a little time, as you can see, because we want lots of images. You can see here, for example, in this part, and it will going to be updated. Yeah, we have our second folder, and we have our second folder, and in that we can, after it is executed, we can see the results. So like this.
Oh, I have all the faces right now.
Okay, yeah,
okay.
Because you did not train it, so that's okay. You can experiment with faces, so you can see and you can learn the ropes, and you can see the differences between the parameters here. You can play with the parameters and do some experiments, so you know what's going on under the hood. You will know and you'll understand it better.
Yeah, they look like zombies.
Yes.
Oh my God, okay. So we should have at least 500 images, right, Mohammed? As you said, also you said that it is not enough, but instead of using faces, how can I add something different?
I have buildings, I don't have faces.
Maybe you have not used my network snapshot here. Did you use my snapshot that I sent you the link to that?
Yeah, I did. In the to define path and directories folders, right? Yes. I use this one. It is ending with.
No. As you see, it is not what I have sent you or something else, because in the folder, as I checked, there is something like let me check it again. There is something like resume FFK FFHQ 1024. It is like something else. You see. You can see in the past, in your past. But it's okay if you are going to work with the past. It's okay because we want just to learn the ropes. We want to do experiments. But after this session, you have to gather your data set or use my data set to train your network, and that's fine. If the network is working, that's fine. So I think, yeah, it takes 2 minutes. So let's go to folder number 2 and let's see the results. And let me just make it as agreed and see what's the results, what's happening here. And they are just showing up. Yes. You can see that we have 250 images, and there are some exteriors of some of them are flawed, some of them are good. There are 2 reasons for that, because my data set, the data set I have collected was not consistent enough, and that was I have done it on purpose because I want you to collect your data set, and because I haven't trained my network that much enough. I just train it for example 2 days, and that is not enough. But we have good results somewhere. For example, this one maybe, or that one, this one. So some of them are good, some of them are not, but that's okay. So we have 250 images here, and let's see how. For example,
sorry, Muhammad, like what do you mean like by train? What do you want like to train? Like what will be, I mean, what could be like more, like you can give it to give like more result or accurate result, let's say. And according to what, I mean, this result, I mean, like is give it to me. I mean, like for example, one of the picture, I mean, like what is the parameter it's considered to give it to me, this result?
You mean what can we do to have better results, or what?
Yes, that's, I mean, the first question. And the second question, like which parameter I can put more, for example, to reach better result?
Yes, okay. So if you, the first question is like, as I said, you should have a consistent data set. As let me show you my data set, because Sigradi here, okay. What happened? Okay. So you see here, it is not consistent. Some of them are tall buildings or big buildings. Some of them are smaller ones. Some of them are from different angles. You see, some of them have different colors. They are not consistent enough, and the number of the images are not really, they are not sufficient, and they are not enough in terms of numbers, because 500 images are like nothing to a neural network. You should gather more images. So, but that's fine, because we augmented our data set, and we end up with 2050 500 images. So you see, the first point is that your dataset should be consistent. For example, all of them should be like the face of the building, like this. For example, they should be orthogonal. Or if you have perspective images, all of them should be, or most of them, for example, 19% of them, 90% of them should be perspective images, or from below or from up. So that is the first reason. And the other experiment that you can do here, you can just play with the truncation PSI. If you want to have better quality, you can just set it to 0 or closer to 0. But if you want to have more variety, and you want to see some creativity maybe in the form, in the images, you should just set it closer to 1, you know? So, yes.
Just also, like, I want to ask you, I mean, like, regarding, like, when you said, like, you have some photo as an elevation and some photo as a perspective, you can also, like, to classify it also, like, by AI, to say, okay, like, classify for me the photo, which is perspective, and so it makes sense.
Yeah, that's a good question, I think. And yes, we can maybe, for example, in yesterday we were talking about classifiers and classification problems, yeah. And we can have a kind of a neural network that do the classification. For example, we have a tool like a web crawler. You know, web crawlers go and search the web and save all the data that they see. And you can train a classifier on a data set and tell it that I just want elevations, or I just want interiors, or I just want, for example, perspective, I just want plan drawings, something like that. And it will just classify them, and it will just split them into the chunks that you want. So yes, you can have other networks, and the result of that network will make your data set. So it is really good to automate the process. It is really intelligent to do that.
Okay, I understand.
Yes, it is very
also, like,
really
I'm just thinking, I mean, like, for example, if we have a survey, like, to ask the people what they are looking for, example, as a design or something like this, to ask the community, I mean, like, it would be possible, I mean, like, to generate something, I mean, like, if we put, I mean, also, like, to integrate this question, or to integrate the answer of the survey with these images, for example, to generate, like, as a design, for example, in the end, that's really possible.
Yeah, it is possible. Let me show you here. And I was working in a research team with other researchers once, and let me find a slide and show you. It is, if you are going to work in TensorFlow, it is called functional or subclass modeling. As you see here, this is subclass modeling API. You create classes and some definitions, But in PyTorch, we do this by default. But in TensorFlow, we have some, for example, sequential APIs or model subclassing APIs or functional APIs. That's why, and that's what you want. You want to have multiple streams of input, yeah? And you can do it. For example, the first input, the first stream of inputs are the questionnaire or the survey and the answers of that. And the other stream of the input is like, for example, images, yeah? And you can do that by doing functional coding in TensorFlow. They call it imperative API or functional. So I have in that data, in those files that I have uploaded to GitHub, you see some kind of I think I have put some example, but if there is not, I can maybe after the class I can send you a file to look at, send you an example. Yeah, because I was working on a research with other researchers, and we have, as you said, we have some feedbacks from people, from ordinary people that they walk, for example, the passerbys and who walks on the streets, and we ask them, for example, 2,000 people to say if that that street is good enough, is it safe enough for women and for kids? Is it beautiful? Is it some kinds of general questions that ordinary people, not architects, ordinary people can understand really easily. And we feed it into our network simultaneously with images of that street. So the results were something amazing, because before we have done it, it was like the accuracy was not that high. So we got better accuracy and performance. So it is really good to hear, to ask it. So yes, it is real. It is impossible. It is possible. Sorry, it is possible. Yeah. So
and like as a data, how many, for example, is there also like to be as the same of the photo? For example, we need at least 500%, for example, or it doesn't matter.
If you are going to because those kinds of data are not images, so data augmentation is really different from data augmenting data of images. So you know, 500 people, it depends on the data set. Maybe it is not enough most of the time, 500 entries. So you should gather a bigger data set. You should maybe have more questionnaires, more people. Yes, you should have more of them.
Okay, I understand.
Yes, because you know, when you are training a network, it needs a lot of data to be trained well enough.
So I mean, like, you mean by the training network, it's meaning like to learn this machine, the machine learning. That's what you mean.
Yes, we can have, for example, in machine learning, if machine learning is good for data, like, for example, as I told you, for example, we have a data set, like, for example, this one, that the features were age, or, for example, female or male, or race, for example, income, a postal code, some data like this, that they are not really complex data like images. Images are really complex, and they need lots of computational resource power to handle. That's because of that, we process images by some deep learning approaches. You know, classical machine learning cannot handle image processing, image segmentation, image generating, something like that. We need deep learning and deep layers and deep networks, lots of layers in between. For example, as I told you yesterday, ResNet from Microsoft, it has I think it has 152 layers. So it has lots of layers to handle sequences or to handle images, you know, and you need lots of data. You see, I can tell you that the main requirement in AI is dataset. Who has more data is going to win the competition every time. It doesn't matter how well how good and how well your model is, your AI model is. It is just a matter of how many data points and how big your data set is. So that's it. You should gather more data set. The first priority in neural networks and AI is to gather more data set. After that, we are going to modify our network and make it stronger or make it more capable. So the first part is going to have a bigger data set. Yes.
I see. Do you have any also recommendation website as an open source data also could be also helpful as to searching about these sources of or this like a code about the survey, this stuff also?
Maybe Kaggle have some. Let me put it in the chat box. Kaggle, yes. Kaggle.com or KD Nugget, if I'm not mistaken. But most of the time, you have to search the web a lot to find the appropriate or the data set you want. Maybe sometimes, because gathering data set is really time-consuming task, and it is sometimes it is not even possible, or it is really expensive, and it takes a lot of time. For example, 6 months or a year sometimes in good research teams. We gather data sets for a year, for example, because data set is the most important thing. So, but you can search the web and you can search Kaggle or KD Nugget. Maybe they have this, but most of the time, for everything we have data set. Google, Facebook, they have the data set for everything, for anything you can think of, but they are not public, they are private. They have it for themselves. So and sometimes there are some companies that they gather data set and they sell it to others. Maybe if you want to have a data set, you should pay some people, and maybe sometimes it is not efficient, or it is not maybe it is expensive to do that. Sometimes you should just if you have some idea in mind, you should just ask yourself what's the problem and how I'm going to solve it. And after that, you should ask yourself, if I'm going to use AI in my work, how am I going to gather the data set, collect the data set, because it is the most important part in AI. If you don't have the appropriate data set, you are not going to be successful.
Exactly. That's why I'm asking, because also like when I just see what you have already so far, so I am thinking how I can use the data which I collected already since 4 years, for example, as a images or as a survey, as a people. So also how I can add this like for the data set as to be like more result, would be like more efficient result. That's I mean the question also, because also I saw one of the examples which they had already done. They did it in MIT. They did like a super nice prototype. It's about like to let the people, according to their feedback, for example, which maybe you know what, like it says interactive feedback, so they will have the result as interactive feedback. So also that was, I mean, like interesting for me. So they say like they let the people, for example, to have this to interact with a physical prototype, and every time, for example, they change something in the urban design, it's interact directly with the feedback, which it's like, for example, is give it this machine. So that's one also of the nice example, which is like have the live interactive feedback.
Do you have the link to that? That's really interesting research you are talking.
Yeah, true. They have the link. I saw it. Maybe I would check it and send it to you also, because
yes, if you do that, yeah, thank you.
Yeah, for sure,
and,
for sure, I will.
Yes, another research we were involved in with one of my colleagues was just through some AR,
Augmented reality.
Augmented reality, yeah. Through some augmented reality environment and those glasses on goggles they put on their faces, we show our participants that some of them were architects, some of them were urban designers, some of them are ordinary people, and we show them a city. The city was not a real city; it was an imaginary city. So we show them through the AR glasses, and they gave us some feedback, and we feed those feedback to a network, to an AI network, and we wanted to see what's the most important factors when you are on a street or in an urban fabric, for example. What's the most interesting part or factors that catches people's eye, that catches their interest? And the results were somehow interesting, because it was not what we think, but the data will never lie. These kinds of things will show the exact things that people want and people do. So it is really amazing.
So it's like real data. That's nice.
Yes.
Yeah, that's nice.
Some say, yes, some say if you want to know somebody, ask Google, because they have the data about us. They know everything about us.
True. Because also, like, for example, Instagram also, like, it's showing us what you like, for example, in the street, for example. So every person on Instagram, it give it to you what you prefer, and also the Pinterest, for example, it give it to you what you like also. So I mean, every social media have its a function, so we can get like this data from there directly.
Yes.
Yeah, thank you very much. I mean, like, it's nice.
Sure, anytime. So I should go. Yes, please go on. I should go.
Okay. I think I have the faces, because in the collab, not the inferences, but the deep architecture, StyleGAN to deep architecture file. To the recent training, we write FFHQ 1024, which is coming with human faces data set.
Yeah, maybe. Maybe you can just update the path to this file, or maybe recheck the path.
I updated. I have already updated it. I updated it.
The result didn't change?
No, it didn't change.
Okay. So let me make you host and see what's wrong here.
Okay. Also, I have a question related with that. So the recent training will train the data according to this data set that I'm writing here, right? The recent training part is the reference that is taking.
I'm not sure what you are talking about.
Okay, I will share my screen.
Yes. So make host. Okay, so please share your screen. Okay.
So this is the main.
So I cannot see. Please wait a little bit. Yes. Okay. So yeah, I can see now.
So we came to here, but we didn't train it, but we entered it. Then I just run time and I interrupt execution. Okay. Okay. And before that, you said that to recent training, we should write this one, which is the data set of the faces from Flickr. And then here, the snapshot path is the folder that you showed us. Well, this one.
So, okay, yeah.
Is this true?
Let me, it is not, yes, this one.
Okay, then I again corrected it and run it. And for generate images, I mean, it is just about to quality and quantity as far as I understand. So when I come to, again, folders, I have zombies like that. Okay, so I think this is the case. Maybe this one has started to train something. I stopped it and it is using faces from Flickr. I'm confused.
Yes, maybe because I've sent you the file, maybe you overwrite it with faces. Maybe you can just download the other one. Maybe you can just download it, not link it to your Google Drive. Because if I want to, for example, if I want to show you the results of that snapshot, the results are in that folder. And let me show you.
Okay, which one? What should I write here, or what should I do?
Maybe that's because you run that code of training on faces, and this one, I mean, it overwrites over that my snapshot of my network, you know. So you can download the file that I have shared with you and upload it to your folder.
Which file are you talking about? If you can be more specific about the file, I can.
Let me check it here first and tell you what I was telling. So this is one, okay. So can you make me a host?
Okay, but so before making you host, I think this part is important because afterwards we're gonna train it. My main question is, I should link the thing here that I want to train, right? For example, if I'm gonna use, for example, Miyazaki's images, I don't know if there's this is actually not enough. It has just 20 files here, but as an example, how will I again link it to here? Actually, I didn't understand that part, Mohammed, very well. Okay. Also, I wanted to share this.
Yeah. So do you mean if you want to train the network for the first time? Yeah.
Yes.
Okay. So let me be a host, and I will tell you what you have to do.
Okay. Okay. You said it will take 2 or 3 days. So for the first training, okay.
Yes. Sometimes, for example, if we were supposed to train a cycle GAN are really heavy, and it needs lots of computational resources. I trained a network of cycle GAN for 4 months, so it was really time consuming.
I can't do it. I just barely understand this part. Style GAN, I will just practice on.
Yes. No, yeah, we are going to stick to a style GAN too in this workshop. We are not going to work with cycle GAN. And you see, this one is the network snapshot number 10. So, and we are going to see the results here. So the results are not faces. They are, if it is loaded, they are buildings. As you see, they are facades. And you see, I think the reason that you see faces in your collab after you want to interpolate them, you want to have some interpolations, is that because in here, after you just start to train it, maybe the FFHQ dataset, the faces dataset, have overwrite, overwrite my network snapshot. So you can just go here and download this one.
Okay, just to link which folder is that one again?
Let me share the link with you. And this is the link. Where is it? Okay, copy. And this is it. So this is the link, and you can access the file. So about your other question that you asked.
Right?
Yes, you download it and upload it to your
Drive.
Google Drive. Yeah.
Okay.
Okay. So in this case, that you want to, for example, for the first time, you want to train your network on, for example, Miyazaki or Studio Ghibli landscapes, as you showed, you have to just start from this one, because this is the data set that the StyleGAN2 was trained on. So it is like we are resuming that data set, and after that we are overwriting our data set over that data set. That's like it. We are updating the weights of the network. StyleGAN2 is some kind of pre-trained network. So we are going to resume it by using its data set, resume it by using its data set and its weights, because they have saved the weights and architecture for us. And now when we want to start to train a network for our own data set, we are going to overwrite it and update the weights. So we are gradually update its weights by our own data set. But whenever you want to, for example, because Google Colab only allows you to run your codes for 20 hours consecutive. So you have to just stop your code, and then the next day you have to, for example, resume it. After that, if you want to resume it, for example, I want to resume on my snapshot, as you see here, this one, this snapshot that I've sent you. So I'm going to just copy it and paste it here. So it is going to resume the training on that snapshot. So it is not going to, again, start from the first step. It will just continue it,
Okay, this was a very important information.
Yeah. So, but you can you should start tomorrow and gather your data sets and everything. And if you have any questions, you can ask me. I will guide you through it. So don't worry, it is not something very sophisticated, and I can guide you through all the parts. So, and let's go to, for example, this part, or yes. Let's see, we have done this part. Let's see, we have done this part. No,
we stopped at the truncation of the latent space.
Yes, and now we are going to generate truncation traversal. So I'm going to specify another folder, because we are going to have some new results. So another folder for the result 3 folder. Result 3. Oh, I should just put underscore. And result 3 and copy the path. So, and put it here. Let me put it here and run the cell again. So it updates the path. Oh, it seems that it is not updated. So let me for one more time rename it folder res 3. Is it okay? Oh, so okay, so I copy this and paste it here and run it. So it is updated. So let's go to this part. Maybe, yes, generate truncation traversal part. So I'm going to just use seed number 1. You can put any number here, for example, this number. So for example, this number, it is okay. So what I'm going to just write 1 and I start from 0 and end at 1. It is like some, we are going to have some frame rates. It is going to be like frame rates of a video. And the incrementation is going to be 0.01. So the result is going to be from 0 to 1. And let's just run it and see the results. And after that, maybe we can create a video of that. So it will take a little bit because it is just doing it gradually, 0.01 plus 0.01, and it goes on until it reaches 1. And after this, after we explore the latent space of StyleGAN2, we are going to work with VQGAN. And let me set up. VQGAN is really simple. You just have to input, let me see, input a text here and maybe some images if you want to. And if you don't want to initialize an image, it's okay. The main part is the text. So let's now just stick to StyleGAN2. And after that, we are going to feed the outputs of StyleGAN2 into the inputs of VQGAN. So the results are going to be something really amazing.
While it is proceeding, I have another question. You said that we are taking this, faces from Filcar because of their weights, right?
Yeah.
Okay. When you say the weights, we are talking about the resolution and it is pixels again, right?
No, the pixels are the, if you remember, let me explain it through the presentation I had last yesterday. Yes, yesterday was our last session. As you can see, let me go on. And here, for example, as you can see, the equation of a line is like W multiplied by X plus B, and B is the bias, and we don't have to pay attention to this now, but W and X is something like X is the inputs, the value of the pixels, and W is the weights, and that thing is going to be updated through the optimizer and backpropagation algorithm, and the AI and the network is going to do this for us. They are some randomly numbers that are initialized randomly, and after we train the model, it will go to shape the weights and make them better. For example, if I want to show you how they are going to get better, it is like this. For example, not here, here. So this is the first iteration that I have trained our network on the data set we have. But you can see that the first iteration is like they are just faces, and they are just a little deformed faces. So the weights had not been updated that much. The weights are just those weights that have been trained on faces data set. So after a couple of iterations, after some iterations, so let's see, you see that the images are going to change. It's because that we are changing the weights. The weights and the bias is like radio buttons, so we can turn on the radio button and update it and make them the way we want. So after some iterations, the weights are going to be updated. The radio button is going to be turned in the way we want, because our data set is facade, and it knows that we want to do it in that way. So you can see that it is going to change, yeah, and it will update its weights. So we are going to see some structure of the facades, but not a real facade or good enough a picture to call it a facade or an exterior part of the building. But after, for example, maybe 2 or 3 days of training, or maybe more, we are going to see these pictures that they are really more likely to call them facades or exteriors or buildings. So that's the process of updating the weights, and that's the impact of weights. So let's go to our results folder, because what was the past? Okay, folder result 3, and here. Okay. A latent space exploration folder result. It is not updated here. Folder result 3. Now it is.
I have a result, it's an MP4, but I have to download it in order to see.
Yes, we have a video, and we have to download it to see. Let me just download it and show you the results. So it is an interpolation between 2 seeds. You can see the gradual movement. So, and
it is cute, but I see the facades that you showed us. I mean, it's normal here, but when I take pictures like PNGs, I am seeing the faces. So I thought that in the video also I will have the faces. I mean, faces transaction, but.
Can you please explain it a little bit, because I didn't.
If you press the video, if I can see your result, I can.
Okay, this result that I have downloaded, do you mean this? So let me show it. This is
okay. I have the same result. I have the same result. Also, I think except me, everybody had the same result for the JPEGs, right?
I have the same video.
Yes, because we are using the same snapshot of the network, the results are going to be the same. But maybe a little difference, maybe in the details, but they are not much difference. There is not much difference between them. They are really the same or very similar. So the result is like this. So you can see there is two facades and the gradual movement and the gradual changes between them. As you can see, that's why in here, in this part, we have seed 1, and we are going to increment it from 0 to 1. So from the latent space, this latent space, to another one. So we have 3 frame rates, and it actually itself is a kind of video. So now let's blend 2 seeds here, so we can see what's the difference between these, and we can just blend 2 seeds and blend multiple seeds in other strategies and other.
Should we create another folder?
Yes, we create another folder because we want to save some new results.
Okay.
Yeah, it is. Yes, it is here. So I copy this and paste it here and run the code cell again and go to, where was it? Blend 2 seeds. So for example, I want to choose seeds, and let me go to that. Where was it? I think number 2. We have generated 250 images. Yeah. So let's see what are our good results and choose 2 of them. 2 of them, and let's see. Maybe this one, for example, or maybe this one. Let's see, maybe seed 11. It is not bad enough. Sorry, it is not that bad. And maybe if you see any good result or good enough results, you can tell me to choose it for our exploration. Which is loaded and it's not loaded. It's going to be loaded. So maybe this one, 177 and 11. So okay, I put where is it? I put 11 and 177, and it starts from -1, or it starts from 0. For example, you can do that, but I'm going to stick to this. But the incrementation is going to be the same as before. And truncation is going to be, maybe let's set it as half between variety and quality. So we have both of them in our images, and let's just run it. It will take time because of the incrementation value is really small. It is really a small value, so it will go to take a little time. After that, we are going to walk through our latent space, our Z latent space, and we have multiple C's, as you can see here. And let's just stick to this one, and let's see when it is finished. Let's see the results. But it is really something amazing and interesting. After that, we can just create a video out of the folder, out of the frames, out of the images. If we have enough image, we can create a video, because a second in a video is like 3 frames of pictures. So we need enough pictures to create a video. And let's see if it is finished. So Ayşegül, I think choosing your Miyazaki dataset is something we will end up with something interesting. So I'm really excited to see the results of your network.
Yeah, me too, but I still, it is very foggy. I don't know where to put this, main data, to which line. I'm sorry, I couldn't get some parts.
Which part do you mean? So it is done.
Okay, we need to have, first of all, a reference data set, as you said, about the weights, the faces, which will be trained.
Yeah.
It should be, as you said, 100% faces, right?
Yes, you don't have to have a data set of faces. You just gather your data set. The faces are there because you can just put it here. You don't have to gather a data set of faces. It is not necessary.
Yeah. It is ready. Yeah. It is ready. I know it. It is ready. We're just putting it there as an input.
Yes.
Then it will become an output, and it will actually transform, as far as I understand.
Yeah.
Okay. The thing is, where will I use the Miyazaki image data set? Where will I import it in other sense? Where will I load it?
Okay, so that's what we did through these parts, We have, let me just do it like this. We just pre-process the data, for example, resize the data, remain the data. That's the Miyazaki data set goes through this part. So, all the images in a folder.
Postmodern style will be replaced with Miyazaki.
Yes.
Data set.
Of course. Yes.
Okay.
And all we have done here is you are going to do that to Miyazaki. So that's as simple as that. But if you have any questions, you can ask me every time and I will be there. That's okay. And so let's see the results of 2 seeds. So this is the result of 2 seeds. Yeah, lots of images. And let's see if they are going to. Okay, so because of the -1, because we started from -1, and it is, you see here, we started from -1, and we see that the results are something something that we did not have, and it is going to change until it reaches 0, and when it reaches 0, it will be our 11th seed. So as you can see, it is going to, let's wait until it's loaded. So it is not loaded. Nothing.
I have from 1 until 29.
Yes, and because of this one from -1 to 1, we are going to see that incrementation, and I don't know why it is not loading the images. Maybe the speed of the internet is not that.
I have mine all loaded.
Okay. So you can see the results, yeah?
Yes, yes. It's turning the building into a house, almost.
Yes, and it will transform into our other seed, because we have 2 seeds here, and we have 11 and 177. So let's move on and create, because it is not loaded and we cannot wait anymore. It is just taking our time. Let's move on with the other part and create another folder for our last part of this Colab notebook. So folder res 5, where did it go? Oh, okay. folder res5. So folder res5, copy pass and paste it here and run this cell. So it is updated, the pass is updated, and yeah, we have here, we start from 0 and we have some seeds, for example 1 2 3 4 5, 1 2 3 4 5 6 seeds. We can have more than that, but that's okay. That's it is not necessary to add something, and we can just adjust it maybe to this part or that part. I think 0.9 is good enough. So, and we are going to explore the Z latent space of StyleGAN, and we are going to have 240 frames, and the frame rate is going to be 24. So it is like a 10-second video, and the diameter is going to be the diameter of the latent space. So it is not something that that is not really important. So we can just do this, and it is going to generate those images for us. And after that, after the images were generated, we are going to create a video out of that images if we want. I think creating a video is good to show the results really in a really interesting way. So the results, it is going to be on this. So let me see if it is finished or not. It is going to finish soon. Sorry.
So while it is proceeding, again, I will ask something. For example, we can totally create something in Grasshopper, 1,000 of images. We can create it with Animate, and we can keep its proportion like 1024 to 1024, and we will have our house modern style thing, right?
Yes.
Okay.
Yeah, it is. I think it is a brilliant way of creating a data set.
Yeah.
So
also in proceeding, we can have a video, and we can take the frames out of the fit. Okay, I will try that one actually, so that because Miyazaki dataset doesn't exist as far as I guess on the internet. If I don't know, I am not able to.
Maybe you can try both of them because you have enough time. Like for example, 3 days or 3 days. Yeah, we have 3 days. So I don't know, maybe you can just do some experiments with one of them, and in first iterations, it will show itself that it is going to work or not. So if it is working, you can continue that. But if it is not, you can go to your other strategy. So that's brilliant to bring up that, because using Grasshopper to collecting dataset is really something that we can do, because most of us are really good enough in Grasshopper. So let's see the results. It is done, and folder this one, okay, and reload it. Folder 5, okay. So okay, now we are in, and frames line C, okay. So it is going to be 240 images, different frames, as you see, frame 0, frame 1, frame 2. And let's see, and the result will show itself better if we create a video out of it, you know? For example, let's go here and specify the main route here as we have, for example, copy the path of folder result 5 and paste it here. Paste it here. Let me paste it. Okay, it is pasted, and just execute this cell, and it is going to create a video for us. As you can see, it is really doing its job quickly. Okay, it is done. So let's be back and let's reload it. So the data will show up here, the images, the video. Okay, a video should be here. Okay, the video is here, and maybe we can see it without downloading it, if it is possible. Or should I download it? Okay, I should download it, and let's download it. Google Drive is really slow. It is like a turtle. So scanning for virus, it is going to be downloaded. Okay. So 14 megabytes is going to be downloaded really quickly.
I did it.
Yeah. Okay, you did it, yeah? Okay, that's good.
Okay, I forgot to write off.
So let's see. Let me see it. I want to see it myself, and let's see what's going on. And okay, here, yep, open folder. Okay, yeah, it is going through all that seeds that we have explored, and some interpolation between them. So these kinds of facades, all we have done till now is something not real. So like those faces of people that they really don't exist. These we can create some buildings that they don't exist based on data sets of built environment. So it is really amazing. So we finished StyleGAN exploration. We can now let me just disconnect it and terminate this session and go to VQGAN, because VQGAN needs lots of resources. So if you're on a pro plan, it is better because we can use more powerful models and data sets. But if you are on free plan, it is really limited. So let's see what kind of GPU we have. So a Tesla 4, it has 15 or I think 16 gigabytes of graphical memory. I recommend you to sync your Google Drive again. So the results are going to be saved in, for example, some folder like this under, I set it under deep architecture using AI in architecture. Another folder, it is called VQGAN clip results. So I'm going to sync my Google. Okay. And let's
wait, I guess mine connected yours.
Sorry, what's that, Angelica?
I clicked to connect my drive, and I think it connected yours.
I cannot understand. Maybe
it was asking that you're going to connect Mohammed. It's not I don't know what file. And I said okay, and then reconnected your drive. I guess I don't know.
Oh, that's weird.
Well, yeah.
Connect to my Google Drive.
I'm gonna weird. Yeah. I'm going to disconnect and then try it again.
Yeah. Okay.
So VQGAN, are we gonna download it?
No, you don't have to download it because you have downloaded already. This is the VQGAN that I have shared it with you as if you remember. Yeah.
It's not asking my drive. I don't.
Oh, that's really weird. Yeah, that's really weird. It should.
You want to show you?
Yeah. Yes, maybe I can make you a host. Okay, and so Angelica, you are a host now. Please share your screen with us. Okay.
I'm gonna disconnect and connect it again.
Yes.
Okay, reconnect.
And reload your web page. Reload this this website. Maybe something wrong with it. Yeah. Sorry. Yes, connected.
And now I run it. See.
Yeah. And
like this notebook is not Google's managed by Google. It was created by Mohammed. Blah, blah, blah. If you may.
Yeah,
okay.
Execute anyway. Yeah, it's okay.
And now it's not supposed to open that box.
Yeah, and now after that, syncing Google Drive. A little, if you scroll down, you see syncing Google Drive.
Oh, okay.
Yes.
Okay,
and
sorry.
Now, yes, that's okay.
Sorry.
And yes, if you can make me a host again. Okay, thank you.
Okay.
Okay, so.
Sorry, I couldn't open it. The same thing with Zivar is happening to me. It is not seeing as a, for the other files, when I double click on them, their collaboratory is opening them.
Okay, you're a host. Maybe you can share your screen so I can see what's going on.
Okay, here, when I double click on it, it is opening.
Please,
okay, sorry.
It is not. Yeah. Yes, you can go on now.
Okay, when I click on it.
Okay, so yeah, it is inevitable because the file extension is missing. You can rename it, rename VQGAN class clip, right click on it and rename it. So after the clip, put a dot and IPYNB. And now it is going to work automatically with Colab. Yeah. IPYNB is a file extension that shows it is an IPython notebook. It is some kind of Jupyter notebooks. They are interactive notebooks that we are trying to run through Colab. So if sometimes this happens, you can check the file extension and you are good to go. And yes, here. So I synced my Google Drive at this cell, and actually you can just do this, and it is going to create a folder for the results. So after that, if you are on a pro plan like I am, just select ImageNet 60K, 60,000, 16,000. But if you are on a free subscription plan, just select this one and deselect this one, because we just want to download one of them. But now we are on a pro plan in Colab, and we can just select this one. And I'm going to run this cell. It will install the libraries and the packages, the models, the data sets. It will import everything. So it will create the environment for us, and we are good to go. So after that,
should we create the file results? You can click results.
No, it is. Let me check if it goes to make it. No, it will pass TMP.
Should you run it? Make a new folder?
No. No. If it is not there, it will make the folder for you. You should just run it. Yeah.
Okay. So run it like that.
Yes.
So should I give a name to the folder? Which I want? Do I need to give a name to the folder?
I have give it a default name as you see, but you can change its name. Like for example, you can, for example, my folder, or for example, iShagul, for example, folder, and it will rename and it will create another folder for you. So that's it. You can change the name of the project. It is optional. You can just leave it out. So yeah.
So where is going to create this folder? There's no path.
So it will create it directly inside of our drive, as far as I understand.
Inside my drive, the root?
Yeah. So did you run it, and is it okay?
I'm just running it.
It's running. It's a problem to run the library and the making folder at the same time, because I started the library and then I went back to run the other one.
Yes, it is okay. You can no, you can just you should just run the make a new folder and set root path, and after that you have to run library installation.
So I have to stop the library. How do I stop the library?
You can just go to this part, runtime, and interrupt execution. Yes. Okay. And after that, you can just do it from the beginning.
It's not interrupting the library.
Maybe just click it one more time or two more times, and it will stop.
Mohammed, are we checking other than something ImageNet 16384? We are not right?
Yes. You know, because we are on pro plan, we choose this, and ImageNet is a data set. So
okay.
Yes.
I hit play then. That, okay.
Yes. And now you see it takes 2 minutes to install the packages like Clip. Clip, you know what Clip is? Clip is a kind of neural network that OpenAI Corporation's OpenAI Foundation has released a couple of years ago. It does that thing that we have done with style GAN latent space. We explored style GAN latent space. Clip is going to explore VQ GAN latent space. So, and how it is going to do this? Clip is going to take text like this: futuristic facade, modern building, comma, trending on art station. It is something that we give the Clip, and Clip will go and explore the VQ GAN latent space and search for the match or the closest match between this prompt and the images that are there in VQGAN's latent space. So it is like
a search engine.
Yes, it is like a search engine. Sometimes. Yeah.
It created. I didn't change the name. Now I have two folders with the same name. One is yours and one is mine. Sorry. Yeah. I tried to put down the name, it didn't accept it, so I kept the same name as yours. But then now I have two folders.
So you can leave it if there is no error. You are good to go. Maybe you can leave that. But if there is an error, you have to delete those folders and start from the beginning. But if there is no error, you can just continue.
Well, running the library. But...
Yeah, it will take 2 minutes. So after that, I just run this code cell, set global parameters, and seed -1 will tell that you have to set the seed to a random number every time. You can just set it, for example, 1, 2, 3, 4. Let me say 1, 2, 3, 4, 1, 2, 3, 1, for example. You can give it any number, but when you give it -1, it will, every time you run this code, okay, so let's stop it. Yeah. Every time you run this code block, it will generate a new random seed. So display frequency is something that the images that we are going to generate is going to be showed or displayed after every 50 iterations. So
the library, sorry, the library went a mistake. It's right.
Let me make you a host so I can see what's the problem. Okay, please share your screen, Angelica.
See that here I have two the same. I just run it, and then I run it, and then 2 times, and then it's right.
Scroll down maybe so I can see the error, and so go down so I can see the error. So module functions cannot set met or okay. You just terminate this session and reload your page, your web page, and do the steps from the beginning, because there is something, maybe something wrong with the modules, so it will restart it.
Reconnect?
Yes. Or... No, just before reconnecting, just reload the web page and then connect it. It's better to do this. So, okay. So please make me host again so I can go through the notebook again. So thank you. And sometimes instead of just terminating this session through this, we can go to runtime and factory reset runtime, hit that. But I prefer to just terminate it to make sure that everything is shut down, and after that I reload it, so I make sure that everything is reloaded again and the modules are resetted. It's better, but we can do this in here, but I prefer that approach. So let's go here, and as you can see, you can have an initial image, so it will the VQGAN and clip will treat that image as a sketch for their image generation based on this text. You see, I prompted here that a futuristic facade modern building. Before the comma is what we want. So it is what we want from VQGAN. And let me show you what is trending on ArtStation. ArtStation is some website that artists or game designers or environment designers, character designers, some kind of artists like them, they put their works on it, and it has a really rich data set. But what is it? We are going to see this, you know, as you can see, for example, 8K resolution for mushroom. Instead of mushroom, we have put it something like futuristic facade modern building, you see. And after that, I use these styles. These are something like styles. You see the differences. For example, pencil sketch is going to generate something like pencil sketches, but 8K resolution is going to be something sharp or something like HDR. So the styles of the image is going to change, but the object is the same. For example, as you can see here, let me, these zoom controls are on my way. So they are a spaceship. All of them are some spaceships. All of them are some mushrooms. All of them are volcanoes. But the style and the graphical style and the image style is different. The aesthetics is different because of this thing we have after the comma. After comma, we have something like trending on ArtStation. I think these keywords are like, let me show 24 images. So 24 images that shows different keywords for different styles. So trending on ArtStation, for example, it is not here, maybe on other ArtStation HD, for example, I can do that, and we are going to have some style like this. For example, if I want to, for example, have a chalk art style, I can put this text after the comma, and we can have lots of other styles. For example, I can, for example, HDR or Balance HD, Behance HD, or ArtStation HD, Flickr, maybe. I put Flickr here, Flickr, and maybe, for example, I go to another picture, another photo, for example, hyperrealism, acrylic, everything. You can just be, you can use all of them or some of them based on what you want. So I'm going to delete Flickr and let's run it without any initial image. So it will take a little time to generate some images, and I set a limit to after 10,000 iterations, it will stop. So you can just make it like this, my -1, and it will run the code block and run the network forever. But I'm not going to run it forever. So after 10,000 iterations, it will stop. 10,000 iterations is a lot. So I'm going to stop it after a couple of iterations. We see the results, and a schema of the results is going to show. So we are going to compare the results, and compare the results when we have we don't have an initial image and when we have an initial image. So the difference is like something, for example, you have a sketch and you are tracing the sketch and you are decorating the sketch when you have an initial image. So you have something specific that VQGAN is going to work on that sketch for you, that image for you, you know? The difference is here. So the first iteration, as you see, every GAN network, the first iterations are like this, a random noise. Random noises are really the things that we input to the VQGAN. Sorry.
Should we run it now? Sorry. Should we
run
it?
Yes, you can run it. You can, for example, you can. So let me check your.
Because it's not running, it's red.
Yeah, the name seed is not defined and the initial image is none. So I think because of that.
Yes, share your screen and I will tell you what's the problem.
Okay.
Okay. So, sorry. Okay. So please scroll up. So you have not run this seed. No, scroll down. You are going too much up.
Okay, this one.
Yes, set global, and maybe you can just change the initial prompt. You can be creative here. You can just, for example, a frog on a wall in heaven, something silly and ridiculous like that. Everything you want, you can just put every text in it. So please make me host again. And so we have something like this. It is going to show up after the first 50 iterations that were the random noise. So let me show you. It is going to be something like that. But if you run it as the same text I have here, you are not going to have the same result I have, because the nature of the GAN networks are based on random vectors. You know, random vectors are the basic of that. So you see, we have some random vector, and after a couple of iterations, for example, 100 iterations, it is going to show itself that, you see, futuristic facade. It is going to shape, and it is going to be something. For example, this is a window, something like robotic windows, something like really, for example, what we see in sci-fi movies. So it is going to be like that after 200 iterations. So you see, it is going to show itself. And this is 100, 150 iterations, and we see loss, and the loss is going to decrease, as you see, because the generator is going to do its job better and better each and every iteration we go on, and the loss will decrease. And you see, the image is going to show itself. So we will just wait for another maybe another set of images, maybe around 300 or 400. I will stop it, because we can do it forever, but we don't want to. We just want to see what's going on. And in this part, we can upscale a photo, because the resolution of this photo, of this image, is 512. 512. So it is not a high resolution image. If we want to upscale the image, we can just run this and just specify the path. I'm not going through that, because it is not very necessary. We don't have to, but you can just do some experiments with that. It is not something very difficult, and you know how to copy the path of something and place it somewhere. So that's it. And you can generate videos. That's it. After all, if maybe.
So sorry, where's the scaling part? So you said image upscaling.
Yes.
How do we define the scale?
You see, if I just, it will just double the resolution, you know.
Okay.
If it is 512, it will make it 1024. Yeah, and you can choose different kinds of models, but I think ESR GAN is better. And if, you know, these kind of VQGAN and StyleGAN, they are going to take lots of storage on your Google Drive. So for VQGAN, I have some piece of code, I have written it. So after that you are done and you don't want all the information to be stored on your Google Drive, you just have to run this cell, and it will delete all the images and the data, and it will free up your storage. So that's it. And you see, yeah.
So Mohammed, this one is which again is taking some input from ImageNet or Coco, Vcard or Fulcar, right? And it is manipulating those data sets by using the keywords that we are assigning from the prompt part. So it works like a search engine. This is it. So the main question is, other than these, data sets, are we able to import any of our data sets to here again?
Yes, it is possible, but it is really difficult, and it will take lots of times because VQGAN is different from StyleGAN and how it works. Every kind of GAN is really, GANs are really notorious for being they are easy to diverge. So they are not, most of the time they are not converging. So if you are going to feed your own data set into VQGAN, there is a good chance it will not converge and it won't be trained well enough, because training again in a good way, it is really difficult. So I have tested and do some experiments with StyleGAN too. So I learn the ropes, and after that I can just teach you how to do it. But you should do lots of experiments to just learn the ropes of it and learn how to do with it. But VQGAN is different and it will take a lot of time, but you can try, but it will be really time consuming. I won't recommend you to do this.
So I have another question. So how this AI can be used efficiently, for example, to identify patterns. Imagine we have a data set filled out with, film noir, okay? Frames. Film noir, it's black and white and detective story. So it has some specific characters inside of it. So I will have a data set, for example, but this film noir also is splitting to eras. For example, from 50s to 70s, the characteristics are changing, okay? And so I will have all the film noir. It is impossible, I know, but film noir, frames from many, many movies inside of this data set. And I want to actually train the AI in terms of this, patterns, so that it can find out really eras patterns afterwards. Is it possible?
So what you are telling me is like some kind of maybe some clustering task or some classifying task, classification or some clustering. So you are not going to generate data as we are doing here with VQGAN or StyleGAN too. You should just maybe you can just watch our yesterday's session, and the basics and the intermediate levels of deep learning and classification parts, and you are going to create or maybe use a pre-trained network that do the classification, for example, VGG16 or ResNet or such kinds of networks that we have talked about it yesterday. And they classify most of the problems really well. So and classification tasks are not really some kind of difficult kind of problems. They are somehow easy, not difficult. You can do that. Of course you can do that. So it's some kind of classification problem. So I'm going to stop this now because we have lots of iterations. I can for better results, let me interrupt it. For better results.
I have a question. Well, I'm checking my drive. Why is that I have all your images from Arc Daily inside my drive in the root?
Arc Daily. So maybe
I don't know. It's all your database is on my drive now, just free there.
Yeah, because I think because you have created a shortcut of my dataset on your Google Drive, so maybe that's because of that. Yeah.
I don't know, because it's the pictures are free there, loose. You know, they're not on any file, and it's just on my drive. And it's not. I don't know. It's really weird. I'm gonna take forever to erase them, I think. I don't know.
Maybe you have just put them that on that folder. You can just delete them because
it's not. Yeah,
if they
it's
are
not on any folder.
Yeah.
Okay.
If it is in the main environment or your Google Drive, you can just delete them.
Okay.
Because the data set that I have provided for you was in a was in a folder, so maybe I don't know what's happened, but you can delete all the unnecessary data. So you see, we end up like something like this. But what if I give it an initial image here? So how can I do this? I can go to Google Drive and go to deep architecture, for example, and go to latent space explorations, and let's see what we have. For example, folder number 4. What we have here, for example, a good image. We choose, maybe we go to that folder number 3. I think we have, no, this one is this one or 2. Let me check it. Okay, so let's see when they are loaded. Okay, so I'm going to use one of them as an initial image for the BQ GAN. Maybe this one, 105, or maybe another one, 136. But 105, I think, will do the job, or 174, maybe this one, or maybe this one. I'm going to try 174 here. So where is BQ GAN? Okay, latent space. Let me move the zoom controls to. Okay, so folder 2, and it was 174, I think. Yeah, yeah, 174. And I will copy the path of this, and let me just save the result of one of these. For example, save it on my desktop, and we are going to compare the results. So this one is going to be first image. So
how you save it?
I just right click on it and click save.
Okay.
But if you want to see the results, let me go to my drive, because it saves automatically, because we synced and we mounted Google Drive. Where is it? We mounted Google Drive here, and we have specified a folder, as you see, and the results are going to be saved in there.
Yeah, so, I saw that. I thought maybe there's another way to save externally. Yes. Okay. Okay.
Yeah. So let me be back here, and 174, and copy the path as the initial image. It is optional. You don't have to put an initial image here or target image. You can have a target image sometimes, but I'm going to just stick with initial image, and let's run it. So it is going to do the math again, and it will generate some images. Of course, the first one will be some random noise, And let's see. No, it is not random noise because we have an initial image. But if we don't have an initial image, it would be a random noise, you know, because the random vector and the random noise every GAN is going to create. So let's wait and see the results. Most of the time, I like to use an initial image because I know how I know the structure is going to be what I want. But sometimes if I want to have something creative, I just stick to the prompting a text, and that's it. Maybe some other different styles like Flickr, or for example, maybe for example, CryEngine. CryEngine is a game engine, and maybe Unreal Engine, something like that. We can just have lots of them based on what we want and their aesthetics, or this is going to make the result before the comma. For example, if I entered a frog in heaven on a tree, it will create an image of a frog in a heaven on a tree that is sitting on a tree. So you should be descriptive most of the time. For example, a frog in heaven sitting on a tree and singing a song, and maybe a happy frog, for example, a happy frog. So you should be descriptive with the text prompt. So you will have better results if you are descriptive enough. But if you said something, for example, a frog, so you have something very random, and maybe you will end up with not a frog, maybe something just green. So that's another thing you have to. So it is going to be like this. Okay. So you see, it is going to have better results because I know what's the structure behind that image. You see, it is more like a facade or a building rather than that image we had earlier. Where is it? First image. Okay. This is something very random, you know, but maybe it is more creative than this, but it is more realistic. Maybe it is more rational, not realistic, more rational. But this one is going to be creative. So it depends on what you want. You see, I like these results a little bit because of the situation, but it depends on what you want. So yeah, that's it. And we can just end it, and we can just answer your questions if you have any questions. And after that, we can just end the session. Yeah. You see, for example, this is like a door. There are some glazing facades or windows, or some skin, some double skin parts of the facade. They are something like that, or they are something like pines or trees, and some lighting here. So you can, let me send you some the keyboards here. I will send these in Discord, so you can have the keyboards and you can treat them as references. So I will send all of them to you now. So all of the time you can save them and you can look at them, and every time you want to create something, you can just use it. It is like a dictionary for you. So 8. So please remember that I want some results from your works that you are going to train your networks, and you send the results to me on Discord maybe, or email, whatever you want, whatever you are comfortable with. But I want those results because Sigradi moderators and directors told us that we need a presentation of the participants' outputs and results. So you can download these images that I sent you to Discord. So let's see what happened here. You see, and it is going to, yeah.
The recordings will stay at your YouTube channel, right?
Yeah, at my YouTube channel, the recording will be there always, but I have recorded the sessions in the cloud of Sigradi, and I have sent you the link to yesterday, and I'm going to send you the link of the recording of today of Zoom application, so you can download it and you can watch it again, or you can just go to my YouTube channel and watch the videos there. So you see, I'm happy with the results. It is something like I want to build this building. It is really interesting. It is really amazing. So guys, do you have any question or any problem, any issue, so we can talk about? Because the workshop is now finished. I have talked about so many things, and I have told you whatever I wanted to.
Are you also directly work on video, or does it have to be a a still image?
Sorry, I didn't hear you very well. Can you say it again?
Do we have to work always on a still image, like JPEG, PNG, or can we work on a video?
Okay, yeah, because of the nature of these GANs, if we want to, there are some kind of generative adversarial networks that can work with videos, but they need lots of computational resources, and we don't have that computational resources. But in this part, if you have a video, for example, let me go here, or maybe some, let me YouTube, for example, chemical patterns. For example, I don't know, patterns in chemical reactions. Maybe let's watch it. Maybe there are some good patterns, and we can use it if it is not loading. So let's just, okay. Let's just, for example, chemical, okay. They are not the results I wanted. Maybe natural patterns. Okay, so for example, we have some videos, for example, a documentary, movie, or video on YouTube, and we can download it, and actually we can extract the frames of that video. For example, a video that is 4 minutes, so 4 minutes is going to be, for example, maybe 50,000 frames of images. So it is a lot. So it is good to create a data set out of that. and we can extract the frames of that video. I will, if you are interested in doing such things, I will send you a short script that is going to do this in Discord. So you can just extract the frames of the video and treat them as images, as what we have done till now, what we were doing with these images, the data sets we have. So yeah, that's it. That's not very different. You just have to extract the frames, the video frames. Yeah.
Okay, I can try if I can understand. It works. Yes. I can try.
Yeah, but if you sometime if you want to work on video and extract the frames, please send me a message. I will send you a short script, and it is really easy to work, like copying the path and specifying an output path, and it will just extract the frames for you.
Frames, okay.
Yeah, sure. So I'm going to stop this, and let me just interrupt the execution. So, okay. So if you don't have any questions, we can end this session, and you can watch the videos. And if you have any questions in future, I can help you with that. So.
Thank you, Muhammad. Like, it was super nice. Thank you for all of your effort. Just I want to ask you also, like, for regarding the Google Drive, which you shared with us, the folder, are you keep it? I mean, because I mean, tomorrow maybe we can just like check it. And the video also, you said like you want to anyway. So also, like, if it's possible, as you said, because also maybe if you just send to us the one which you told me about the survey, you said like you already have something like as an example. So
yeah.
And also if you have the references also could be help us, also would be super helpful for us, I think.
Yes,
just like through
if you want to something, for example, some other tutorials about AI, if you want to grasp or know more about AI, yeah, it would be perfect, because I myself, I was when I first started to learn AI and started to work in this field of science, it was really difficult, because we are architects. We don't know how to code, or we don't know these kinds of mathematical things. And I was through some difficult moments that really hard for me. But you know, for example, Coursera is a really great website. I will send the courses that maybe will help you a lot with TensorFlow or PyTorch or AI or such things, or deep learning, image classification, image processing, everything. I will send the address of that to Discord, so you can just I will share it on Discord maybe tomorrow or today, and you can just go there and enroll in those courses, and they will issue you some certificates, and they are really amazing, because most of them are taught by the pioneers of AI, like Andrew Ng, or those guys from Google or IBM, such guys. Yeah, it is really handy and helpful.
Yeah,
and about the other thing that you said, what was that you said?
About the survey, like the collecting data from the community.
Yes. Okay, functional API. And so, yes, I will send you, I will put all of these on our Discord channel. So let me see. So yes,
and also, like, thank you. And also I want to ask you, I mean, the result, I mean, which you had it like today, for example, it's considered as a deep learning, or what? I mean, like it's about like I don't know. I mean, like how to call it. Like you said, like that's the thing which is, for example, run it. It's like the processing. It's a deep learning or machine learning or
okay. So yes,
AI or.
You know, let me show you this, and it was what we have talked about in the earlier of the first session yesterday.
Exactly, because
so
now I mean maybe it would be
yes
helpful now after we got all this information to get back. I mean to see.
Yes, sure. You know, AI is a very broad and extended field of study. So it will contain machine learning, the classical machine learning, that approach that we input the data and the answers, and the machine learning algorithms are going to generate the rules for us, you know, the patterns. And deep learning is a very specific subfield of machine learning. And what we are doing here now with StyleGAN and GAN or something like that is another subfield, another very specific and in-point subfield of deep learning. So we called it generative deep learning. And after that, we go to generative adversarial network. So you see, it is going to narrow down. It is like a niche inside another niche and inside another niche. You see? But all of them are AI, and the subfield is machine learning, and the subfield is deep learning, and the hierarchy, you see. But there are many other approaches to machine learning and AI. For example, evolutionary algorithms is somehow some kind of AI, but they are not related to machine learning and deep learning. Or we have in field of machine learning, we have such things, for example, XGBoost or random forest on random trees or KNNs, those kinds of things, but they are not deep learning. And in deep learning field, we have other things, for example, processing, natural language processing, or image processing, or speech processing, handwritten processing, or signal processing. They are deep learning, but we are focusing on image processing. And in image processing field, we are focusing on generating images through generative adversarial networks. You see the niches inside other niches, a niche inside another one and another one. So there are some doors inside doors.
So we can say that there is a difference or like comparison, or like all they have the same processing, but maybe each one, like for example, deep learning, it's have more detailed processing than AI, for example. But it's a part of AI for sure.
Yes, it is a part of AI for sure, because AI is about learning. The computers are learning something. So, but deep learning is a part of machine learning, because we have some statistical, for example, probabilistic modeling in AI, that it is not machine learning. They cannot handle complex problems that we face in machine learning. And machine learning also, they are not they are like shallow networks, they are not deep networks. So deep learning is derived from here, you see, because they have lots of hidden layers, and they are deep layers. They have lots of layers and lots of hidden layers between inputs and outputs. So we call them deep neural networks or deep learning. Yeah.
Yeah, so it's about like the detail processing.
Yeah. So it is about the approach and the kind of data set and details. Yeah, of course. More about the approach. Yeah.
Yeah, I got it.
Yes.
Like, for example, like the example of like the classification of in the iPhone, for example, when they classify the picture, for example, for each one, and they categorize it. That's what we can say it. Like, for example, every time it's getting like more approach and detailed approach, that's we can call it deep learning, for example.
You know, image classification is a kind of a task or a problem, but the approach is, for example, deep learning or machine learning. But machine learning is not going to be classical machine learning or other approaches. For example, you know, let me just write it here. Okay. For example, we have machine learning, so it has some subsets. For example, random forest, RF, or random trees, RT, and deep learning. So they are not deep enough. So there are some approaches to machine learning. You know, there are some kind of approaches, and deep learning is another approach. But deep learning is really getting lots of attention and attracting lots of attention these days because it is the prominent approach nowadays. Most of the complex problems are just solved through deep learning. So you see, it is an approach. So it is, and when you choose your approach, it is related, and it is based on what kind of question or what kind of problem you have. Sometimes you just don't have to use deep learning. It is not as efficient to use a very high computational resource on some simple, for example, tasks. For example, classifying people into male or female by their height. This is a very simple kind of problem. You see, we don't have to go through deep learning approaches, but some approaches like image processing or image classification or speech classification, speech recognition, or such things, they are very difficult, even for our brains. We are doing it subconsciously, but it is really difficult. So you see, yeah.
For example, if I say like I mean, regarding to my, in the case of my research, if say I like, for example, if I want to use this deep learning, for example, to recognize like how much the destruction of the building, for example, so the status of the building. So it could be, for example, like if help me, and what could be the data which I needed, like as a photo or also as a data which, for example, use the Karamba data, for example, and Karamba analyzes, which is good. So I should like feed this machine, for example, with this data, so they can recognize the building directly. If this building, the status of the building, let's say. So yeah, that's, what do you think about this?
You know, when you are going to face a problem, like you said, if, for example, detecting the cracks of a building or such things, such problems with the structure or the building, it depends on the situation. For example, sometimes you can just have the images of the torsion or bending of structural elements and give it to a classifier, and it will classify those images into if they are destroyed or devastated, or if they are good enough to continue their life cycle. But sometimes, as you said, for example, Karamba, it's better to use the data from Karamba to feed it into our network. For example, I have not worked a lot with Karamba because it was not my field. but I know that it will simulate and optimize the structure, and so many parameters are involved. As you see, it is a very sophisticated plugin, and you can, yeah, you can have a good data set of Karamba and just feed it into your neural network, and you can, after that, you should just do experiment. It is not a magical formula that you say that if I do this, I will be successful in this field. No, you should just do experiments. For example, you are going to have the data from Karamba and feed it into your network. After that, you are maybe you can expand your research and extend it. For example, you can have the images of the structures, and this is another stream of the input, as we have talked earlier in this session. And I told you, you can use imperative or functional APIs of TensorFlow. So it will make your research or your tool more robust. You know, you have multiple streams of input. But I guess if you are going to, I think if you are going to work with Karamba data, it's better to just in your first steps, you work with those Karamba data set or data that you are generating or receiving from Karamba, to feed it into your neural network. And after that, if you see that it is working, so we are good to go. I can now add other sources of data, other streams of data. But you cannot, at first, you cannot just have multiple streams of data. Maybe the question was really good enough and brilliant enough, but you just overkilled it with many sources of data, and the, you know, the network is not going to perform well. You should just there is a very famous saying between coders and programmers that they say every big and huge program that is made was a real little, once it was some real little programs that we merge them together and stuck them together and make a big program. So you should just have your first steps really small. You should just baby a step, you know. But this approach you have is something interesting. You can work on it, and I think it is going to be a great kind of research. Yeah.
Thank you. I mean, like, because I'm just thinking about like what would be the useful, for example, of the machine learning for sure. I mean, like if we have a structured beam model, let's say, and I can, like, for example, make the optimization or the analysis by the Karamba, and they will give me the result directly. But I mean, like if I want to use the AI in this like big deformation, for example, city, and for example, the machine learning, it would be helpful, as you said, maybe in the way how, for example, I can recognize the status of the building by the image of the building. So I mean, like by one image, for example, as you said, if I feed it, let's say, if my data input, it will be like the data of the Karamba, the data of the structure, the data of the building status, all that, it will be feeding inside this, for example, machine learning, let's say, and then it will be give me, for example, by the picture, it will be helpful for anyone like to recognize the status of the building, and how could be, for example, if this building it would be stable or no. Not like, because not all they, as you said, not all, for example, they're using Karamba. So it's not like, or like not all, for example, they know the status of the building. So it's still, I mean, there is a basic way to know the status of the building. So maybe it will be the artificial intelligence or the machine learning or deep learning, whatever, it will be the way maybe like to helpful, for example, to have the typology of this destruction building by knowing like in which picture, for example, I know the status of the building. Yeah.
Yeah. I think what you have in mind, first I should tell you that you should specify the question of the of the research for yourself. You should just fix it, because I think you have some ideas, but it is not very obvious. Yeah, but you want to know what is it useful to, how is it useful to use AI, and in this case that you explained, this problem is going to be solved, for example, through some classification, not image classification specifically, maybe some kind of data that you have. It is based, but it is a kind of classification. You are going to classify the status of the building, for example, as you are talking about. So you are talking about you want to distinguish the phases of the building's status. So you see, you want to see if the building is in a good shape or not. So it is some kind of a classification problem. You should just analyze the problem in your mind and see, is it a classification? Is it I want to generate something or not? Or because you don't want now to generate something, you just want to know the status of something. Yeah, and you want to know
that's
if
the
it
first
is
phase. Then like I want to generate.
Yes, and so for example, if you want to just you just want to know the status, classification algorithms are going, classifiers are going to help you. After that, if you want to generate something, you can use GANs, or you can use VAEs or autoencoders or variational autoencoders, for short VAE or AE. But I think for the generation part and generation phase, it's better to use GAN. GANs are better to use, you know, because they are here to fix the problems of other generative algorithms like autoencoders. So yes, but you and pay attention to something that I have told you earlier, and I'm saying it now again. First of all, you should just declare the problem for yourself and define the problem and the question. After that, you are going to know how to collect the data set. If you don't have the data set, the most powerful AI is not going to work to help you. Yeah, it is very important.
For that reason, I have to know the specific parameter what it needs this machine, for example, to know how could be collected in the way. For sure, we have a lot of data, but I mean, like we have to say, okay, like which data would be useful. I mean, like to have the result. It's not, as you said, it's not a magic. So just give it the data set and it will give me the solution. But for sure, I mean, like I need like the typology of the building status, and then it will be the next step, which I told you about it, how we can integrate the community participation and the integration of the community with this building, for example, the status, to generate new images. So that's, if I want to tell you, maybe that's the obvious question for me, how we can integrate the AI for this, I mean, in the post-war city. So, I mean, that's, I mean, like the phases which looking for, I mean, the first phase is like to classify, as you said, the classifying of the building status, the classify the people, classify the community, and then the next one, it will be generating the typology, for example, based on this classification and based on the data set. So data set, classification, generating.
Yes. Yes. First of all, in your case, in your specific case, you are going to just have some classification, after that some generation, and you know, you can generate something if for example, those courses that I've told you may help you just generate your models or typology in different ways rather than images, maybe, or something like that. But if you want to work on images, you can just stick to these things that we have talked, and you can just read more about it. So when you know about more tools, so you will become more capable of handling the problems, you know. Yes.
But about what you said, like, sorry, about what I read, like you said, I didn't hear it.
Yeah, I said that you mean that website that I told you?
Which
yes,
one?
Coursera. Yeah, Coursera for the courses.
Ah, the one
if
which
you
you
want
send it.
Yes.
Yeah.
But there are lots of courses, so maybe you go there and you will be confused which course should I enroll. I will and you can join our Discord channel. Other participants are there, so we can discuss about it, and I will send those courses that you are going to start and you are going to need at your in your first steps in our Discord, so we can talk about it and have discussions on that. Yeah, you can join us here.
Yeah, that would be perfect. But I mean, as your suggestion, I mean, regarding the AI, it will be, I mean, the things, it will be I have to focus on the data set, the classification, and the generating typology, you know? And the data set, it will be for me, I mean, the building status, the people, the community, the survey, that's the data set for me, it would be.
Yes. But you know, when we are facing a research problem, at first when we don't we have not involved in that research, when we are not involved in that research, we think that I'm going to do this and do that, maybe, for example, have some questionnaires, some surveys. But when you go through the phases of the research, you see that most of them are unnecessary. Why should I do this? Yeah, you should be careful with that. Yeah, and yes, and maybe if it is not an obligation to use AI in each problem, so maybe you should just pay attention to this. We need tools to facilitate the way we do our job, but the main thing and the most important thing is, what are we going to solve? We want, as researchers, we want to focus on the questions, on the problems of society, on the problems of architecture, urban fabrics, everything. But nowadays, most of people are obsessed with tools. So, you know, learning new tools is good, but you should know the problem, you should know the question, you should specify and declare it. It is the main point of being a researcher.
Yeah, true. I mean, like, for sure. I mean, but I mean, that's what actually I mean doing since 4 or 5 years about this. But I mean, like, now I am thinking in one point. I mean, like, as it's like it's about strategy. So I mean, like, how you can use this, like, for sure, use this technology in somehow in one phase, like integrating the big data, integrating the social media, integrating the AI, for example, in one of the phase. I mean, for sure, I mean, there is still a lot of architects, they say, okay, the machine wouldn't do anything about that. But I mean, like, we have to think which phase could be. Maybe like it would be the classification phase. It would be perfect for me, the classification phase. Or could be also like generating, could be the data set. For sure, I mean, we have a lot of data. We have the 3D scanning, we have the point cloud, we have the people, we have the history, we have the urbanism. All this is a data set. We have to consider it. For sure, it's not just building and people. But I mean, like, later, how could be useful? For that reason, if I want to say what is the question, for sure, I would tell you how we can use this AI in these things. So because it's not so clear for us, as you said, because maybe we will experiment these things, but maybe in some point we will say, okay, like, it's not useful for us.
Yes. Yes, I should go. Please.
Sorry, I'm interrupting. Well, in VQGAN, I tried to generate a video, but I couldn't manage it. It is giving file not found error.
Yes, in VQGAN, let me check it, and there are 3 cells and file name video, download video. Okay. And let me run it. Okay, name taqaddam. Okay. The error is that something is missing. The name is TQDM or taqaddam is not defined. Is it the same for you?
No.
Okay, let me make you a